Welcome to Ask and Learn.
So there is an object of, in this problem, object of mass m, and it is connected by a spring. It is kept like this, sorry for this, on the, let's say it's attached to a fixed support, and then they're saying that this support, which is there, it is fixed, the object is fixed with a spring, and the mass is pulled at a distance. So the mass is pulled to some distance, and the mass is pulled by a distance. It says stretched initially x naught from this initial position, so it will oscillate back and forth in simple harmonic motion. Obviously at this point the spring will have elastic potential energy, which is maximum half k naught x squared, and this object will come momentarily to rest. Therefore the kinetic energy is going to be 0. So kinetic energy is 0, and the elastic potential energy at this point is this. When it comes to the middle point here, it will have 0 elastic potential energy, while kinetic energy is going to be half mv squared, and then it will come to some place here and it will continue oscillating back and forth. So we need to draw the potential energy. So since potential energy is given by half kx squared, so it has got a parabolic function. So we'll draw a graph for this here like this. So the graph is going to look like this, a parabolic function here, and this is u of x, and on this side there is going to be displacement. So let us assume that this point is x naught, which is the maximum displacement. So now we can have the object starting from here, and then let's say somewhere in the middle, this position will be kinetic energy, and then this will reflect its potential energy. So the object, when released, will gain kinetic energy and lose potential energy until it reaches the equilibrium position at this point, where it will have maximum kinetic energy and maximum speed. Then it continues to move towards the left, in this direction, losing kinetic energy and gaining potential energy until unless it reaches the same point on the left, which is x naught at this position, and the motion reverses. So it will continue in this oscillatory motion between x is equals to 0 and x is equals to x naught. So this is the graph, of the object, the potential energy u versus x. This looks like.